Okay, welcome back. The second important trigonometric function in which it is very useful to know the derivative is the cosine function. Now, we're actually going to go step by step in the limit process to find what the derivative of cosine is. So, let's start out with the limit definition. Limit, we're going to immediately apply the cosine in it. Let's say h approaches 0 of cosine x plus h minus cosine x divided by h. If you're unwary or unsure of where this formula comes from, please look at my previous videos. Okay, so we have the same problem that we had with the sine function. We have cosine x plus h, but no need to worry. We can expand this using the trigonometric addition of angles formula, which I will prove in a different video. X plus h, in this case, simplifies to cosine of x, cosine of h, minus sine of x, sine of h. Alright, so in other words, cosine of x plus h expands to the following, which we can replace right there. Alright, so we're going to immediately go and replace it. Minus cosine of x, the whole thing divided by h. Now let's do some house cleaning. Like before, we're going to find common terms. In this case, the only common term I actually see is this cosine and that cosine. Let's group them together, and then let's factor out this common term. In this case, cosine of x leaves over cosine of h minus 1. Okay, and then we have minus sine x minus sine h. Remember, this is the same thing. If you expand this right here, you'll get the exact same thing. I just reordered it. And the whole thing was divided by h. Alright, now using simple algebra, we know that if we're going to divide by h, every term takes its own division of h. So, we have cosine x, cosine h, minus 1, divided by h. And then we have minus sine x, sine h, divided by h. Alright, now we're going to use a really important limit of trigonometric functions that we should know by now. Cosine h minus 1 divided by h, remember, actually simplifies to 0. I'll explain where this comes from in another video as well. So, because this is 0, 0 times cosine of x, or times anything in that matter, just gives you 0. In the same manner right here, sine of x divided by h, we don't know. Let's try sine h divided by h. We didn't know because they're different variables. In this case, sine of h divided by h, using the limit, remember, the limit as h approaches 0, this equals 1. So 1 times minus sine x is just minus sine x. If you simplify everything together, you get minus sine x. In other words, after applying the limit definition and simplifying, we get that the derivative of the cosine function that we see right there is actually negative sine of x. We're going to go right along and discover what implications this has in its graphical approach. Alright, welcome back. We found out that the derivative of cosine of x is equivalent to negative sine of x. Now we're actually going to see how this works out graphically. So, I'm going to graph it. The first function that's being graphed is the cosine function. Second function is going to be negative sine of x. Alright, so right here is the function we have. The first function drawn is right here. That's the first function, and then the other function is a derivative function. But before we actually go into this, we must step back and think, what is a derivative in the first place? A derivative function calculates what the slope is at any given x for any function. In this case, if we have a function and then we have its derivative, the derivative is going to calculate its slope. Well, we can't, without a calculator, we don't really know the slope of every point, specifically in the trigonometric function, but we can make simple observations at known points. In this case, when we see the horizontals. So, in this horizontal right here, at x equals 0, there's a slope of 0, or horizontal line, at the cosine function. Now, if there's a horizontal line, that means the slope is 0. Now, do we see a 0? Yes. Negative sine of x actually reports the function itself as 0 at that point. Alright, let's look at other points. So we have cosine function, we see another horizontal right here. Slope of 0, in other words, the slope is 0, that means that the function, negative sine of x, has to be 0 at that point. And we see right there, it's also 0. And we can see this at different points right here, another horizontal line, it's 0, and so on and so forth. So this actually shows us graphically how and why cosine of x, its derivative is negative sine of x. Till next time.